Jimmy, tell me a little bit about what Mitsubishi Hyper Heat is and how it's different from standard heat pump models.
It's really in the heating capabilities, right? So, there's two different heat pumps made by Mitsubishi. There's what we call standard heat and hyper heat. The real difference there is in the heating season. So the indoor units are all interchangeable. They're all pretty much the same from hyper to standard. The outdoor designs very similar. You wouldn't notice a difference there. The compressor is definitely different. The compressors are a little bit bigger. We have a little bit more coil surface, so we have a little bit more area that we can disperse either AC or heat. Um, the holy grail difference is going to be anything below, I would say, 12, 15 degrees. It's still going to heat 100%. So we're getting 100% heating capabilities out of that system at 5 degrees. The new Sumo line, minus 5 degrees, it's still giving 100% heat. So it's really in the heating capabilities of that system.
So a standard heat pump system, you get down below, what did you say, 15 degrees or so, it's going to start to lose its efficiency in terms of heating.
Yeah, so they still work. It doesn't shut off. It just becomes very expensive to run, and we're losing a good percentage of the compressor. So if it's a two port 20,000 BTU compressor, standard heat, anything below 20 degrees, we're going to start losing the actual BTU number on a scale. I think we lose about 60% of it down to 5 degrees. So it'll in fact still operate. It just number one is running very expensive, and number two, it's not the proper size if we're looking to heat that space.
So talk a little bit more about those coldest days and how a Mitsubishi heat hyper heat system, will maintain heat output below 0 degrees.
The systems are amazing. I'll tell you, it's I heat my own house 100%, no backup heat with these systems, and I can vouch that I have three small children, and we maintain 72 degrees throughout the whole winter on these systems. How it basically works is it's called a scroll compressor, right? So you got a picture. There's a little compressor inside of these condensers that spin, and inside that scroll compressor spins at very high RPM. So when we're calling for heat at a very high load, that system's going to ramp up, or we call it turning up, right? And it's able to do that because of what we call flash injection. So it's coming in the backside with a little piece, a little tube of Freon to recool that compressor and allow it to run at such a high RPM and spin so fast. That's what it's doing. It's using Freon on the back door to basically cool it off and cool those bearings off to, have it last and create that heat.
And you said that it's able to generate 100% of the heat down to minus 5 degrees. You said.
Yeah, so there's a different lineup. So there's what we call hyper heat, and then there's the new lineup, which is called Sumo Heat. But regardless of those two, they're both cold climate heat pumps made by Mitsubishi. The heating is amazing. The performance is 100% at either minus 5 or 5 degrees. So it's still giving, if it's a 36,000 BTU compressor, you're still getting a true 36,000 BTUs of heat at those ridiculously cold temperatures. It's amazing in, the heat pump industry. It really is amazing.
And then what happens at that minus 13 degrees temperature? You're losing a little bit of efficiency, but it's still able to heat the house?
Yeah, we're not shutting off. I mean, we're still producing heat. We're still producing heat very well. We're just losing a little bit of a percent of the actual size of the compressor. We're not losing a lot. So you're still going to get very good heat. We're just going to struggle a little bit on the load, right? If we're sized at an 18,000 BTU unit inside, we're probably going to run a little bit smaller than that in those, we don't see it here in the Boston area much, but if it got that cold, you're not going to have to move out of your house, right? We're still going to heat that house. It might just be a little bit chilly.
Yeah, and talk about that a little bit. You mentioned that in the Boston area and New England in general, we don't see a lot of days where it gets below zero. I mean, it's really, even we just had we're in February here now in 2026 recording this, and we just had a cold spell where. Yeah, we had a couple of nights when it did get down to 1 degree or 0 degrees or something like that, but that's that's really quite rare, and we really almost never see anything -10 or any kind of temperatures like that, right?
Yeah, no, it's very rare. So our software that we use, it's set to Boston Logan temperature. So we use that as our benchmark. And our software that we use is by code, we want to be heating, at a 10-degree mark. So they want us at 10. When we size a house, it's on a 10-degree number. We have to maintain that, 70, 68 degrees of heat in that house. It's basing off a 10-degree day, which if you look at a Boston Logan heat chart of that year, you hit it right on the head, John. There's not a lot of days that we're going to be below that temperature, if any. This year, like you just mentioned, we did have a very cold snap, but it's very rare. This has not happened in many years if you do look at that chart.
Do you still recommend having some sort of a backup heat system? And if so, what kinds make sense here in New England?
Really depends on the house. This is a big one, right? This is something that we talk about daily with homeowners. Um, if it's a old house, that's breezy and leaky, it's I would love to leave a secondary system in place for the first year just so we're comfortable, right? This is a different type of heat, and I have this conversation with my homeowners every day. Let's just say we're moving away from, an old steam heat system that's just a choo-choo train, but that choo-choo train works very well for that old, 19th century house. Um, it's just a different type of heat, right? We're on the wall and we're kind of doing heating in one location versus, if you had heating in that house previously and we were on a few different walls with that hydronic system. I would love to leave backup heat in those older, bigger homes just so everybody's comfortable through that first. We'd learn a lot the first cold week is what I tell my homeowners, right? Then, if you're comfortable, I'm comfortable, and we're good to go. Um, problem areas are always going to be, right? Bathrooms, hallways, and basements. These are the three heavy hitters that we look at when we transition these homes off of like whatever type of fossil they have, either propane, oil, or resistance. How are we going to heat those spaces, right? We really have to dive into that. A lot of contractors will dodge that question or not even bring it up. We totally put it in front of the homeowner. And again, we just want to make sure everybody's comfortable when we leave that house. Um, the system will perform like we just talked about. It'll perform 100%, 5 degrees, -5, some systems down to -10. But do we have it everywhere, right? Are we leaving bathrooms out, basements out, or it's hard. It's a hard question. It's not for every house, right? I would say if it's a tight house, a new house, or been remodeled, yeah, we can heat that all day with heat pumps with no backup heat. But it's a hard question, right? We do recommend leaving backup heat when we have to.
Okay, and it's a conversation, like you said, that you need to have with the homeowner because it really depends.
It's different. Every house is different. The bigger, older homes, I would tell you, before walking into that house, I'd be way more comfortable leaving some type of secondary heat, just at least for the first year.
How do you size hyperheat correctly so that it's comfortable for the homeowner without short cycling or inefficient running?
Yeah, that's a big one. Manual J's. You have to do a load calculation on the house. We have very advanced software that will come in, will scan the house. It looks at things like your windows, your outside walls, your floors, your insulation. Is the roof below ceilings, or do you have an attic? It looks at all these principles, and then it will spit us out basically a blueprint with a load calculation. So that's the first piece. I would say that's 50% of, now we have the information that we need. Now we have to figure out equipment to match to that. Here's where a lot of contractors we see daily basis go wrong with this. They don't select the equipment to fit not only the heat load, but we also have to match the cooling load out of one system. So I would say start with the manual J and have somebody very knowledgeable if you're going to be installing heat pumps in your house with the equipment side of things. What is the turn down ratios? Do we hit both my high heating load and my low cooling load? We really need that to fit to keep the system from short cycling.